So I talked to several people about the homework. And one of them said this very interesting thing. He said, well, you have to realize I never learned C++. And of course, he has been programming in C++ for about 8 years, but he never learned C++. And that is a very common thing. There is nothing wrong. I mean, it's actually, he was just honestly admitting something which happens to be the case for most people. They never learn C++. And most of us never learn programming languages. In some sense, I never learned C++. I was just very fortunate that I worked next door to the guy who designed C++, so I could sort of ask questions. Why is this doing that, and whatever. This is how we learn. We learn by osmosis. We ask each other questions. So I will assume for a second that my friend was right, and I will generalize from him to the rest of the class. I'll say, you don't know C++, I don't know C++. Let us figure out all together some basic things about C++. And of course, C++ looks very scary if you look at the language description. It's about 2,000 pages long and written in incomprehensible, legalese. And you stand no chance to ever understand this 2,000. I mean, it's just way too long. But let me make following claim. I claim that you could write wonderful C++ if you learn about 5 pages of basic code, right? Not 2,000, but 5. And anybody can. And today I wanted to start, just to step a little bit back and start with one such page, which would show us how to write class, which we were supposed to write, but we will do it in a little bit more simple way. We will simplify our task. We will try to write a class which possesses 2 properties. First of all, it is the most simple class possible, meaning it will have no code whatsoever, or almost no code. On the other hand, it is going to be the most complete class possible, meaning it will have all the language details about class writings which you need to know. Right? And while doing that, we will be discussing all kind of design choices and discussing why we do this or do that. And the class which we are going to write, as some of you figured out, is called singleton. Let me right away, this is Ryan told me when we discussed this class, he said, Alex, people will be very confused. That is invariably so, by the way, no matter what I say. But in this particular case, what he meant is all the people read the design patterns book and are familiar with singleton pattern and would think that's what you're talking about. No, I wouldn't do that, would I? So what I'm talking about something very, very simple. No singleton pattern, but a class. And I could have started with a class which is a little bit more complicated, class called pair. Some of you might have heard. It is in the standard, std pair. Pair has 2 things, right? Well, guess what? Singleton is just one thing. So let us try to write a class which takes some type and create a singleton containing this type. Right? So that's an interesting task because we'll have to figure out what do we have to provide. And while doing it, we will learn how to write all of these things. Right? First of all, we're going to write this word, which some people get scared. We'll have to say template. Why do we have to say template? Because we want to write something which takes one type and returns another type. We want to write, mathematically speaking, let's forget C++ for a second. Want to write a type function, a thing which takes type and returns type, generates new types. And the template is the mechanism in C++ for doing just that. There are, of course, other type functions. There are even type functions in C. What are type functions in C? Anybody could let me know? A function which takes a type and returns another type. For example, but the most basic one, the one which you use daily, the one which you don't even think about, of course, it is a type function. Int is a type. Int is not a type function. Dereferencing takes an object, not a type. So we want to take a type. We want to take an int and convert it to some other type. Size_t does not return a type. This is a wonderful example of a type attribute, something which maps type into type def. Type def is not, it doesn't create types, you know. Type def doesn't do anything. It's literally not. So what is a function? How could you create something out of int? Anybody? Macro for sure has no effects on type system. Guys, you are looking far and wide while the array is close, but array is not quite a type in C. So just say the next thing which comes to mind after array. Well, the next thing which comes to mind is actually when you say array is a pointer. Star is a type function. It takes type, int, double, or something, returns another type when you say T star. I mean, you don't write it in a function way, you write it postfix, but it is logically a type function, something which takes a type and returns a different type. Do you agree it returns a type? Int star is a type, right? Yeah. So now, here we're going to start with template. And just for the time being, we'll say type name. And by the way, let us discuss it quickly. There are two things I could have written there. I could have written three, but let's not even. So I could have said class T or type name T. And in some sense, there is no difference. It will work both ways. Why did I say type name? Sort of the convention is that if you say class, you probably expect this thing to be a class, right? If you say type name, it could be a class or a built-in type. It could be an int. So that's why the conventionally we say type name. Remember, I want to get to a point where we type identical code. So therefore, I'm going to discuss every single character I'm going to write. Right? And argue, say, Alex, you should have written T. T, by the way, capital T is a conventional, again, sort of, obviously I could have said small u, and it would have worked. But there is a convention that for formal parameters of templates, we use capitals, right? Because these things, as we shall see, I'm not going to fully describe what it is. They are concepts, and we capitalize concepts. It's an accepted convention. So I just said the T means concept. What do I mean by that? I mean by that it would be nice to figure out what are the requirements on T. Okay? So I put // but we will have to write requirements. We'll have to say T is something or other. Yeah? But let's wait and see, because the requirements are going to be quite remarkable. We will discover some. Right? And then we could say something like struct or class? Should we say struct or class? What's the difference? So the only difference is how they treat public and private. They're fundamentally the same. Let's remember that. There is no difference between struct and class, except if I say struct, the default is public. If I say class, the default is private. And here we come to this amazing thing. So let us say struct temporarily, but we have to argue. We have to figure out, is it struct or class? And you say, I mean, how do we argue that? We'll figure out. Okay? So, and we agreed that singleton is our name. And again, why? Because if you go and check a dictionary, or, you know, people say singleton, pair, triple, quadruple. Since we want to have something like pair, but smaller, singleton is a natural term, right? And the fact that some gang of four used it for, you know, other purposes could be safely ignored. It's a good term for a singleton. So, yes?
Back to the struct versus class. Isn't there like a silent agreement that struct is for simpler things that don't have like fancy things like VMT and stuff, and classes for?
I don't know. I'm not part of that agreement. No. I think there is a rule, but we need to worm it out. We need to figure out what's the rule.
It's not a language limitation, but just
No. Yes, and I'm saying yes, there is a convention, but that's not the one. For example, let me put it like that. If you let me argue again. Remember, we have to always argue. So he says, if it's complicated, many fields, then it should be a class. So it's like singleton is a struct because one, pair is a struct. How about triple?
It's not about the number of attributes.
What it's about?
Well, say a presence of virtual functions.
Why would virtual function require you to be a class?
Not a requirement, a convention.
Why? Again,
Struct comes from C, and there were no virtual functions there.
well, templates come from C++. Templates for sure post-date virtual functions. I was there, so I could attest. No, I actually claim there is a more profound reason. I'm not arguing with you. You are correct in the sense, let's try to find a reason. But the reason is deeper than just virtual functions or complexity. Okay? Let us get, we will answer the question, but maybe not this very second. Okay? So, no, this is very, very good. So, and what we know is we're going to have inside this thing called T, since it's going to, you know, that's the whole point. It's going to have thing called, and I think conventional name for such thing. Here I cannot claim some profound mathematical reason, but it seems that majority of people would call it value, right? So some people would abbreviate to val, but people who know me know that I'm morally, remember I'm the guy who restored QUE to unique. So I restored UE to value. So we look at that, and so the question arises here and now. So obviously we sort of need a value. And there are some people who would say, let us make value private, because that's C++ way. That's object-oriented way, whatever that might mean. That is a good way. Let's make it private. And let's provide people with two functions set value and get value, setter and getter, right? And that, of course, is good because, it makes your productivity go up, and you could report that you wrote 2 more lines of code. So that's good. But on the other hand, let us see why it is actually idiotic. It is idiotic because whatever you said, this thing, let's assume you provided both setter and getter. Then you could read the value and write a value, yes? You could do anything. But you want to do it in a peculiar way, not the way the language intends, which is using just writing there. There is this assignment operator. No, you want to write a function. It doesn't protect anything, right? So, and here we're right at the border of figuring out when we need to make things private. I'm not objecting to making things private. Of course, certain things must be private, but of course not the things which you could arbitrarily change through function. Because making them private makes absolutely no sense. So what do we need to make private? Okay, let me see if you could guess. What? What does it mean?
Things on which invariance must be reported.
Yes. What does it mean?
That you can't set any value.
You cannot set any value. For example, canonical example is, when you implement something like vector, it has a pointer to memory area, yes, where all the data is allocated. You don't want to have this thing public, because if somebody writes into there, you're just going to lose this long chunk. You're going to be leaking memory. There should never be writing there before you first deallocate somehow, right? So, as John said, you have to preserve invariant. But here we don't have any invariant. So again, that is the fundamental. We have to sort of, is there invariant? If there is some condition, we need to assure that the values cannot change without satisfying this invariant. Then, yes?
Since the type t is a parameter, there's nothing preventing t being pointed.
Yes, and so this is fine.
If it's a pointer, then when externally set it.
No. If I have a structure with a point, I don't want to have any invariant. This is just going to be a structure, angle, curly braces with a pointer in it. I don't want any protection. I want to convert any type. So let's think about what is our task. Our task is to convert type T somehow, by hook or by crook, into, I do not see anything, into brace T brace, right? So we don't want, for example, if we have in star, we want to convert in star to brace in star brace. But it's still, we don't want any other semantics than the semantics of, right? We don't, if you do something else. But this just an operation which takes a type and puts it into a struct containing just this type. Do we see it? So let me get rid of this. So we sort of see that this has to be public, and as we will observe, whatever things we will write after that will have to be public. We will never discover any private function, right? So if there's no private function, if there is nothing private in this stuff, call it a struct. It has no invariance. It has nothing to, right? And people say, no, but it's not C++ way. Yes, it is C++ way, let me assure you. Right? There is, of course, sort of C++ imaginary way, sort of people, but it's not, I mean, you have to take the language as it is. It allows you to say struct, say it. Right? Otherwise, you'll have to say class and then to say public. And as my friend Paul just said, he's not going to do it because it will increase typing. We should find the most minimal way of saying what we want to say. So we agreed that we need to have value t. Now, let us see what we need to do. And I claim there are going to be 3 groups of operations which we need to provide on these things. First, 3 main groups, 3.5. There's one group which will make it semi-regular. What should it include? Well, to make it semi-regular, remember, semi-regular types, anybody remembers what they are? We talked last time. See? What are semi-regular types? Types which are almost regular. Yeah? Okay, that's a good start. So, what are regular types? Anybody remembers? Copied and compared by equality. Yes? Something like that. So semi-regular, they could be copied, but equality was forgotten. Right? We'll talk about it. So semi-regular has to be copied. And we agreed to, in order to copy, we need to provide what? Copy constructor, assignment. There are 4 things. Once and for all, 4 things. Copy constructor, default constructor, assignment, and destructor. 4 things. Right? And by the way, when we will write this class, what you will do, you will print this class and put it on your wall. Because any other class will have all these things. And more importantly, you will have this file. Because the amazing thing, what you do, you start any class by taking this class, and then if you use Emacs, doing replace string. And you replace singleton with whatever you want to name it. Right? And you're going to have a whole bunch of stuff. Then you just need to fix 2 or 3. You will see. It's very, very simple. So semi-regular, we need to provide several things. First and most important thing is copy constructor. Yes?
Why default constructor?
We will get to it. Well, just in 1 second. I started writing copy constructor. I tried to explain. Okay, if you want me to do it right now, I could do it right now. Yes. But what we want, we basically want people to, when we implement this class, to feel as good about it as they feel about int. Right? It has to be natural. Right? So all the functions they would normally write for int would just work for this class. Not, of course, plus, minus, divide, and stuff like that. But the basic fundamental stuff should work like that. And there are 2 ways people do things. Some people write, when they want, they write T, A, B, yes? To initialize something. And some people say, well, it's hard in my context. What I want to do is I'm going to initialize this thing to B or C depending on some condition. Have you had situations like that? So what they do, without thinking, they write T, and then they say, if something A equal B, else A equal C. Have you seen that? Have you done it? It happens. Sometimes, of course, the first way is nicer if you can initialize right away. But sometimes you cannot. You have to wait for something. So you do that. And what we expect for any normal or regular class is that TA followed by A equal B is identical semantically and hopefully identical even in terms of performance to TA equal B. Right? That's my answer. This is why we want default constructor. We want to be able, both idiomatic expressions, to work without thinking. Again, sort of, in some sense, right now I'm doing something which nobody ever does. I'm trying to explain to you the logic. But, for example, when most people, when they say use STL, they don't know what's the logic behind. But they still somehow, I for sure know that you guys don't, but you still manage to use vector. Because vector behaves, I claim, in somewhat natural way. Right? Sort of when you just, yes?
Is there any circumstance where the assignment operator and the copy constructor not compatible?
Let's think about what will happen. As I say, the immediate consequence is that you will be irreplaceable and you will have job security. Right? This is, we have lots of code like that. And I know that people who write this code are irreplaceable because, there is no rhyme or reason. It's sort of written in a complicated way. The problem is that I want that after I quit, you appoint Ryan to maintain my code. And Ryan will be absolutely interchanging these two versions like without thinking, will you? He will, because he assumes that that's how things work.
So if that's the case, why kind of language you enforce that only one of them?
That's a very good question. We will get to it. Yes, yes, yes. That's a very good question. We will address it shortly. Okay, guys, I have to occasionally, I want to be interactive, but I couldn't just go on every path, especially since, there is some plan, however crazy it might be. So yes, we will be discussing that. Of course you are right. And I just want to say that semi-regular things, let us, we have to sort of make some progress. It's about 20 lines, and I'm writing, one line every 10 minutes. So that's, we'll do. But this is good, because in some sense, we'll write these 20 lines, which are the most fundamental lines of C++ code there are. So this is why I'm so keep interrupting, do not hesitate. But I still want to start writing our copy constructor. So how do we write copy constructor? Any constructor, this is syntax, has the name of the type. So we say singleton. And the copy constructor, by definition, is a constructor which takes the element of the same type and it takes it by constant reference. Why not by value? Yes, because you could do it by value, but you will get amazing non-terminating code. Because what does it mean you pass by value? It means you call copy constructor. So, right? This is the definition. So it's a little thing, but it's worth noticing it must be by reference. singleton reference, and it's common to call things like that X. X is a very good thing. You could also call it A, but I prefer X for variables. You know, A's are more like constants. Remember from first algebra? Yes.
Singleton needs to have a template parameter.
No, it doesn't. That's why we're doing it. No, it doesn't. Inside the template, what? He wants angle bracket, singleton angle bracket, C angle bracket. No. Okay? So these are good things to know. This is why we're having this class. You don't need to. Right? This code could be actually pretty nice. Right? Because in some sense, how do you know that something is a natural thing in the language? It's natural if it's easy to write, if it's natural to write. These things, you know, they ironed it out. They spent, 35 years figuring out how to write this nicely. Right?
But they still let you write it not nice.
We will get to that. And that, look, I will address it in a minute. Just in a minute. And then we put a colon. Right? To colon allows you to initialize the members of U from whatever was given to you. And therefore, we need to make value x dot value. Yes? Do you agree with that? And then what do we do after that? Nothing. Right? So it's a very nice thing. You write it. By the way, do we need to write it? No. As we shall see, there are things which are called implicitly declared. So let us write a comment here. We will say could be implicitly declared. What does it mean to implicitly declared? Anybody knows? Meaning if I didn't do anything, if I just delete this line, compiler will synthesize this line. Some people call this synthesized constructors. Official term is implicitly declared. Right? Sadly enough, I'm not going to stress. Well, I probably should do this. I should just put it on this line. Okay, so, out of 4 things, we did 1. So what is the second thing? Default constructor. Well, this is so very simple. By the way, this is all wrong. You guys should tell me when I put bugs. Why is it not doing it? I know. My apologies, guys. Escapes X C++. And now I have to make it big. Otherwise, nothing works. My apologies. So the second thing I need to do is to, is it too small? Is it good? Okay. So the second thing is default constructor. And default constructor is constructor which takes no arguments. And to call it, we write TA, by the way. We don't write TA open paren, close paren. This is just, I've seen people doing it, and, it's so singleton. And what do we need to do? We actually, amazingly enough, do not need to do anything. Because what is the semantics which we want? Anybody could tell me what's the semantics of the default constructor? What do we want? No, I don't want you to tell me. I want them to tell me. These 2 people have no voice. You want a default constructor value. Basically, you want whatever t default value of t being constructed. So why don't I do that? And I don't want these two guys say.
Because the default value is type specific.
It is type specific, but why wouldn't I try to construct? I actually could have done this, right? Which would explicitly call a default constructor. Well, guys, because the convention is, the rule is, it calls anyways. Yes?
The one corner case is if you pass a pointer for t, the difference is that one will be default constructor, aka will be garbage. And the other will be, this one will be value constructor, which means that.
Yes. Yes. But since you do not know what you want, okay, let me now tell you, okay, this is a very good question, and let me explain why you really don't even want to know that. Let me explain what you should sort of assume. You should assume, you see, the only thing we want to do with default constructor is to construct something, and then what did we do? Remember the little piece of code I just wrote? And then assign into it. So basically, my firm advice, always use default constructor only in the context where you want something where you would assign. Sort of the two properties of default constructible value of t on which you should rely, only two properties, is first, you could assign to it. It's not quite enough. You need a second property. What's the second property? You should be able to destroy it. Of course, you shouldn't be answering questions. But again, guys, in some sense, there are C++ experts, and my goal is to make everybody a C++ expert, not to prove that experts are experts. So the whole point is that you should not rely, there are so many people who would rely on the fact that in one context, int will be initialized to 0 by default. And if you want it to be 0, make it 0. Assure that it is the value you want, right? Sort of, but basically the stuff which you want default constructor to do is to create you something where you could assign. But of course it has to be destructible, otherwise some terrible things could happen. Okay? 2 out of 4. By the way, I said that the first one could be implicitly declared. What about the second one? That's okay. As long as our experts keep their mouths shut, you will never be able to answer the question, because it's just, so very complicated. The answer here, we're getting to the point where, again, there are some quirks. Like this one, the copy constructor, will always be synthesized, right? Unless you do something, declare private, right? The default constructor will always be synthesized unless you have other constructor, right? And therefore, it's very unsafe to depend on it, because it happens to you time and time again. Like right now, we could say, we didn't need to write this line because we have no other constructors. But believe it or not, before we're done, we will have other constructors. Why will we have other constructors? Just why I'm saying we'll have other constructors. Anybody? Okay, except you. Why do we need other constructors? And you. Yeah, otherwise, how do you get anything? If you construct a type which has only copy constructor, it's, you could just copy nothing. I mean, you need to be able to put something in there. And that's the constructor which we will eventually write. By the way, it's not part of the requirement for regular type. You could have a beautiful regular type, which, by the way, could you tell me best example of a regular type which doesn't need any constructors, really? I mean, it needs copy constructor, default constructor, no other constructors. Okay, you could say. Now I'm allowing even heavy artillery. When don't you need other constructors? A whole bunch of classes where you don't need other constructors. These classes, no. Containers need constructors. Vector has constructors. Lots of them. No, but it does have. It's really convenient to be able to construct a vector, out of a range. But what you never need to construct out of something. Example. Singleton you need. Let's go one step below singleton. A class with no members. There are very many classes. We say, I mean, why would you have a class with no members? Oh, we'll have lots of classes. Before we are done, guys, we'll have classes with no members up to here. But they'll have no constructors other than this because, they have no constructors, like std plus. Giving you an example from the standard lab. You don't know what it is, but we'll get to it. Right? So, yes?
But you still don't need that constructor here because you can create an empty, you use the default constructor to create the value and assign the value.
How do I do what? I mean, this is a default constructor.
So you use default constructor and assign the value by accessing the member variable directly.
You mean copy? I don't need copy constructor, you mean?
No, you don't need other constructor is what I'm saying.
But that's default constructor. If I don't provide it and I give you another constructor, then this constructor will disappear. Right?
We could still use this. The point is we could still use the class. If we didn't, by just
How?
assigning the member variable directly.
But how? No. Remember, we still want to be able to write idiomatically CA.
Yeah.
Yes, we need default constructor, but we don't need any other constructor other than default and copy in this case.
Yes, but it's, in some sense, this is unnatural. Because what you want a connection between T and singleton of T. I mean, they are related types. We'll get to that. This is very good. We can, indeed, the absolute minimum would be to provide just regular type functions and rely on writing there. But give me a few minutes. I don't know. Speed I'm going. But it's all your fault, guys. So yes.
So that we write the same code, do we need the...
No, absolutely not. I wrote it to show that that's what it will do. But of course, we agreed that we need to write the most minimal way, right? That's the most minimal way with the same semantics. Yes, thank you. Andrew. And I didn't look at the list with pictures. He criticized me for not knowing names by heart. So guys, I mean, it's tough. I barely know my own day. Yesterday, you don't believe it. Huh? Yesterday, I sent mail to a whole bunch of people here, like Anil. Did you read email from me yesterday? How was it signed? Greg, how was my email to you signed?
Let me check.
Okay, he will, I will start working on the distractor, but he will tell us.
Oh, yes, Alice.
Yes. See? So, sadly enough, I am at the point of, not knowing my own name. So now, remember 4 things. We need to write a destructor. And again, so singleton could be implicitly declared, but sometimes it will not. So it's a good habit to always write it. It's not a big deal. It's a tiny little line. But what happens, and happened to me time and time again, you write a class, you don't have other constructors, then you put additional constructor, and bam, a whole bunch of stuff stops compiling. Very unpleasant, because something which used to work no longer works. That's of course, it shouldn't be like that, but that's how it is. So again, singleton, that's how we write destructors. We say not singleton. That was a joke, ha ha ha. So, do we need to do anything? No, because the semantics is that all the members are going to be destroyed. So the destructor for T, which we want to call, will be called. And the same thing applies to this guy, meaning he could be implicitly declared. And literally, we don't need it, but in some sense, let's write him. Because you see, we're writing a general template. I don't mean template, I mean general pattern, general form of a class. And that's how you write destructors. And finally, we write an assignment operator. And that is such pain you would not believe. Right? Why? Because, first of all, we need to figure out what to return. And we cannot possibly figure out. If we're sane people, we will say assignment operator should return nothing at all. It's just assigns and being done. But we do not live in sane world. I'll be talking, this is very important point, guys. So right now, we have to return the ref. Let me write what it is. And what? Singleton. Pardon me. Singleton ref operator assignment, and it takes, again, what should it take? It should take, roughly speaking, the same thing as copy constructor, right? So at least there. And we better make it const singleton x, as we did before. And what is, why the const, of course there are people, and I met people like that, who are very, very clever assignment operators which modify the right side of the assignment. Again, guarantees full employment and all other things, and promotion, you'll be principal scientist before you say 1, 2, 3. But don't do it. Resist. Because promotion is not the only thing in life. So make it constant. Do not modify the guy you take as an argument. Don't zero him out. But so we take singleton x, and what do we need to do? We need to, again, write our value, right? Is assign, again, we're sort of saying assignment will do the assignment. Assignment will do the assignment of x dot value. Everybody agrees? And then a magic incantation. We'll explain why. We'll so return. No, we do not return this. We return star this. This is magic incantation because it will allow somebody to write code like A takes B, then takes C, and whatever, right? You should not write code like that, guys. Right? So, and here there is a thing which we need all agree upon. We have to follow standard convention, and since they demand that we do that, we should write it their way, but we should never rely on it. That's a bad feature, right? Basically, my advice, which I will occasionally preempt things. I was not supposed to say it now, but I'll say it now. That, like Paul and I, we firmly believe that things like assignment, like plus plus, like minus minus, like plus equal, should be used only as statements. So that anybody who writes an expression containing assignments inside, containing plus plus inside, again wants lifetime employment. And he's doing bad thing because his successors will have difficulty figuring out what the code does. Wow, it talks. Okay, so we do not want to do that. Okay, so I think we are at a good point to go grab pizza because we are done. No. One more thing. And, of course, what do we know about assignment? We know the same about copy constructor, destructor, and almost always about default constructor. It will be implicitly declared for you with exactly this semantics. Basically, these guys which I wrote, if you don't write them like that, the compiler will invisibly insert them. But it's good for you to know what it will insert. That's what it will insert. And again, it's good for you to know what is the standard sort of set of functions which we will use. So we're done with semi-regular. So before we start on regular, we will go and do, I hope, now they got pizza. I have this firm belief that no programmer could survive without pizza. And last time I was very disappointed. They got us sandwiches, which, no. It's not, programmers don't eat sandwiches. Not real programmers. Of course, it should be cold pizza, but they cannot do that. Okay, let's go eat pizza.